While statistics has been around in one form or another for a very long time, the modern field of statistics really came about in the early 1900s. A century ago, people started using the one mean z interval, like we learned in chapter 16, but instead of using the population standard deviation, which they didn't have, they replaced it with the sample standard deviation, hoping that it would work about the same. And for large samples, it did work pretty well. But for small samples, there were issues. And the reason for that is just like the sample mean is going to vary from sample to sample, the standard deviation that we calculate from the sample also varies. So that extra variation was causing issues with both the p-values in a hypothesis test and the margin of error in a confidence interval. William Gossett, a quality control engineer for Guinness, is one of the first people to investigate this. Gossett's job was to check the beer's quality by performing a hypothesis test. The process he used should have incorrectly rejected about 5% of the good beer, but instead it rejected 15% of the good beer. So the reason for that is that just like in a confidence interval, sometimes it will miss catching the true population mean. There's also an issue with a hypothesis test that there's a small probability that you're going to get the wrong result. And so you set that significance level to help account for that. So the way he set his significance level, 5% of the time, he expected it to come to the wrong conclusion, which was toss out the good beer. And instead, 15% of the time, it was telling him toss out the good beer. So to account for this extra variation that comes with using our sample standard deviation, we have a new family of models called a T as in tiger distribution. So this looks very similar to a normal distribution. It's still unimodal, still symmetric, still bell-shaped, but where the difference is that in a normal distribution, like we did with the one mean z, as in zebra, those tails drop off very quickly, and that's why we don't expect to see outliers. In a T, as in tiger distribution, the tails do not drop off quickly. They drop off slowly, and so that means we have more probability left in the tails. It turns out that the amount of probability left in the tails depends on the sample size. So the smaller the sample size, the more probability that's out in the tails. Because of this, we have a new parameter introduced called degrees of freedom. And to get the degrees of freedom, you take the sample size and subtract 1, or it's n minus 1.